Hi all, myself Kavitha Santhosh, Assistant Professor, Department of Computer Science, Naipunya School of Management, Chetala. My topic is operating system. Here we are going to discussing about following points: general definition, importance of OS, how OS hides complexity, kernel mode and user mode, services provided by OS, OS as a resource manager, types of OS and future OS. Let's start from the definition. An OS is a program which acts as an interface between computer system, users and the computer hardware. It provides a user-friendly environment in which a user may easily develop and execute programs. Otherwise, hardware knowledge would be mandatory for computer programming. So, it can be said that an OS hides the complexity of hardware from uninterested users. In general, a computer system has some resources which may be utilized to solve a problem. They are memory, processors, I/O, file system, etc. Next, we are discussing about importance of operating system. Operating system has more importance for all the computer system because every types of computers are lifeless without using the operating system, because operating system allows the interface for interacting between the users and all software which are installed on the operating system. An operating system is the most important software that runs on a computer. It manages the computer's memory and processors as well as all of its software and hardware. It also allows you to communicate with the computer without knowing how to speak the computer's language. Next, we are discussing about how OS hides the complexity of hardware. Let's see a figure. In this figure, we can see that operating system is between system programs and hardware. It is used as a predefined library for hardware-software interaction. Here, system programs apply to the installed OS so they cannot reach the hardware directly. Since we have an already written library, namely the OS, to add two numbers, we simply write the following line to our program, that is C equal to A plus B. In a system where there is no OS installed, we should consider some hardware work as follows. Assuming an MC 6800 computer hardware, then we have to write the following hardware code, that is LDDA 80, that means loading the number at memory location 80, LDAB 81, that is loading the number at memory location 81, add B, that is adding these two numbers, STAA 55, that is storing the sum to memory location 55. Here we considered memory locations and used our hardware knowledge of the system. That is, if there is no OS in our system, we have to write hardware programming. Without a software, a computer is effectively useless. Computer software controls the use of the hardware, that is CPU, memory, hard disk, etc., and makes the computer into a useful tool for its users. The software side of a computer can be divided into two programs, libraries and operating systems. Each layer hides much of the complexity of the layer below and provides a set of abstract services and concepts to the layer above. For example, a computer's hard disk allows data to be stored on it in a set of fixed sized blocks. The operating system hides this complexity and provides the concept of files to the application software. In turn, an application program such as word processor hides the idea of a file and allows the user to work with the document instead. The operating system must shield the details of the hardware from the application program and thus from the user. The operating system has to substitute a set of abstract services to the application programs to replace the physical hardware services. When applications use these abstract services, the operation must be translated into real hardware operations. Next, we are discussing about kernel mode and user mode. In a more simplistic approach, in fact, OS itself is a program. There are two modes of operation in the operating system to make sure it works correctly. These are user mode and kernel mode. User mode. The system is in user mode when the operating system is running a user application such as handling a text editor. The transition from user mode to kernel mode occurs when the application requests the help of operating system or an interrupt or a system call occurs. The mode bit is set to 1 in the user mode. It is changed from 1 to 0 when switching from user mode to kernel mode. Next is kernel mode. The system starts in kernel mode when it boots and after the operating system is loaded. It executes application in user mode. There are some privileged instructions that can only be executed in kernel mode. These are interrupt instructions, input output management, etc. If the privileged instructions are executed in user mode, it is illegal and a trap is generated. The mode bit is set to 0 in the kernel mode. It is changed from 0 to 1 when switching from kernel mode to user mode. Next, we are discussing about services provided by the operating system. First is program development. OS provides a variety of facilities and services such as editors and debuggers to assist the programmer in creating programs. Typically, these services are in the form of utility programs that, while not strictly part of the core of the OS, are supplied with OS and are referred to as an application program development tools. Next is program execution. A number of tasks are needed to be performed before we can execute a program. Instructions and data must be loaded into main memory. I/O devices and files must be initialized and other resources must be prepared. The OS handles these duties for the user. Next is access to I/O devices. Each I/O device requires its own peculiar set of instructions or control signals for operating. The OS provides a uniform interface that hides these details so that the programmer can access such devices using simple reads and write. And next service is controlled access to a file. The OS must provide protection mechanism to control access to the files for different users. Certain files can read only or write only or execute only. The OS must enforce the access mechanism. And next function is system access. In the case of shared or public system, the OS control access to the system as a whole and to specific system resources. Next is error detection and response. A variety of errors can occur while a computer system is running. Internal and external hardware errors such as memory error, device failure or malfunctions. Software errors such as arithmetic overflow or underflow, attempt to access forbidden memory locations. Operating system cannot grant request of application. Last service is accounting. Accounting consists of collect usage statistic, monitor performance, used to anticipate future enhancement and prepare billing information. Next, we are discussing about why OS is known as a resource manager. What is a resource? Resource can be either a hardware device or a software construct that facilitate computers' programming task. In this figure, we can see a computer system and I/O devices. Computer system consists of memory, processor and I/O controllers. I/O controllers as an interface between computer system and I/O devices. Internally, an operating system acts as a manager of resources of the computer system such as processor, files, memory and I/O devices. In a computer system, we know that there are two types of resources, hardware and software. CPU cycles, memory space, files, programs, etc. are software resources. Motherboard, CPU, memory and all input-output devices are hardware resources. In this role, the operating system keeps track of the status of each resource and decides who gets a resource for how long and when. In a system that supports concurrent execution of program, the operating system resolves conflicting requests for resource in manner that preserve system integrity and in doing so attempt to optimize the resulting performance. OS is responsible for controlling and managing the various resources of a computer system. The OS functions in the same way as an ordinary computer software. That is, it is a program or suite of programs executed by the processor. The OS frequently relinquishes control of the processor and must depend on the processor to allow it to regain control. Next, we are discussing about different types of operating system. Following are the different types of operating systems: simple bash system, multiprogramming system, multiprocess system, desktop system, distributed operating system, clustered system, real-time operating system, and handheld system. First, we are discussing about simple batch systems. In this type of system, there is no direct interaction between user and the computer. The user has to submit a job to a computer operator. Then, computer operator places a batch of several jobs on an input device. Jobs are batched together by type of languages and requirement. Then, a special program, the monitor, manages the execution of each program in the batch. The monitor is always in the main memory and available for execution. Advantages of batch systems: no interaction between users and computer, no mechanism to prioritize the processes. Next operating system is a multiprogramming system. In this, the operating system picks up and begins to execute one of the jobs from memory. Once this job needs an I/O operation, operating system switches to another job. Jobs in the memory are always less than the number of jobs on disk. If several jobs are ready to run at the same time, then the system chooses which one to run through the process of CPU scheduling. In non-multiprogrammed system, there are moments when CPU sits idle and does not do any work. In multiprogrammed system, CPU will never be idle and keeps on processing. Next is time sharing system. Time sharing systems are very similar to multiprogramming system. In fact, time sharing systems are an extension of multiprogramming system. In time sharing systems, the primary focus is on minimizing the response time, while in multiprogramming, the prime focus is to maximize the CPU usage. Next is multiprocess system. A multiprocess system consists of several processors that share a common physical memory. Multiprocess system provides higher computing power and speed. In multiprocess system, all processors operate under single operating system. Multiplicity of the processor and how they do act together are transparent to the users. Next is the advantage of multiprocess system: enhanced performance. Execution of several tasks by different processors concurrently increases the system's throughput without speeding up the execution of a single task. If possible, system divides tasks into many subtasks, and then these subtasks can be executed in parallel in different processors, thereby speeding up the execution of single task. Next is desktop system. Earlier, CPUs and PCs lacked the feature needed to protect an operating system from user programs. PC operating systems therefore were neither multi-user nor multitasking. However, the goals of these operating systems have changed with time. Instead of maximizing CPU and peripheral utilization, the system opted for maximizing user convenience and responsiveness. These systems are called desktop systems and include PCs running Microsoft Windows and Apple Macintosh. Operating system for these computers have benefited in several ways from the development of operating system for mainframes. Next is distributed operating system. The motivation behind developing distributed operating system is the availability of powerful and inexpensive microprocessors and advances in communication technology. These advancements in technology have made it possible to design and develop distributed systems comprising of many computers that are interconnected by communication networks. The main benefits of distributed systems are its scalability and speed. Next is advantage of distributed operating system. As there are multiple systems involved, user at one site can utilize the resources of system at other site for resource intensive task. Next advantage is fast processing and other is less load on the host machine. Next, types of distributed operating system. Following are the two types of distributed operating system used, that is client server system and peer-to-peer systems. Let's discuss client server system. Centralized system today act as server system to satisfy requests generated by client systems. The general structure of a client server system is depicted in the figure. Many clients request and receive services from a centralized server. Client computer provides an interface to allow a computer user to request services of the server and to display the result the server runs. The file server system provides a system interface where client can operate, update, read and delete files. Next is peer-to-peer systems. The growth of computer networks, especially the internet and the World Wide Web, has found a profound influence on the recent development of operating systems. When PCs were introduced in the 1970s, they are designed for personal use and are generally considered standalone computers. With the beginning of widespread public use of the internet in the 1990s for electronic mail and FTP, many PCs became connected to computer networks. In contrast to the tightly coupled systems, the computer network used in these applications consists of a collection of processors that do not share computer memory or a clock. Instead, each processor has its own local memory. The processor communicates with one another through various communication lines, such as high-speed buses or telephone lines. These systems are usually referred to as loosely coupled systems. Peer-to-peer is a decentralized communication model in which each party has the same capabilities and either party can initiate a communication session. Unlike the client-server model, in which the client makes a service request and the server fulfills the request, the P2P network model allows each node to function as both a client and a server. Next is clustered system. Like parallel systems, clustered systems gather together multiple CPUs to accomplish computational work. Cluster systems differ from parallel systems, however, in that they are composed of two or more individual systems coupled together. The definition of the term cluster is not concrete. The general accepted definition is that clustered computers share storage and are closely linked via LAN networking. Clustering is usually performed to provide high availability. A layer of cluster software runs on the cluster mode. Each node can monitor one or more of the others. If the monitored machine fails, the monitoring machine can take the ownership of its storage and restart the application that were running on the failed machine. The failed machine can remain down, but the users and the clients of the application would only see a brief interruption of service. There are two types of clustered systems: symmetric, asymmetric, and parallel clustering. First is asymmetric clustering. In this, one machine is not hot standby mode while the other is running the applications. The hot standby host does nothing but monitor the active server. If that server fails, the hot standby host becomes the active server. Next is symmetric clustering. In this, two or more hosts are running applications and they are monitoring each other. This mode is obviously more efficient as it uses all of the available hardware. And next is parallel clustering. Parallel clusters allow multiple hosts to access the same data on this shared storage. Because most operating systems lack support for this simultaneous data access by multiple hosts, Parallel clusters are usually accomplished by special version of software and special releases of applications. Next is real-time operating systems. It is defined as an operating system known to give maximum time for each of the critical operations that it performs, like OS calls and interrupt handling. The real-time operating system, which guarantees the maximum time for critical operations and complete them on time, are referred to as hard real-time operating systems, while the real-time operating systems that can only guarantee a maximum of the time. That is, the critical task will get priority over other tasks but no assurity of completing it in a defined time. These systems are referred to as soft real-time operating systems. Next, let's discuss about future OS. The operating system of the future will cater to your every needs. The era of mobile computing has been established. Operating systems are hurtling toward a new paradigm. Devices are functionally always connected to the internet, by extension connected to things like smart speakers, lights, and even to another computer, phone, tablet, or TV. The operating system of the future is not just for one device, rather it supports an entire ecosystem. Amazon is demonstrating that with Alexa, a custom voice-based operating system that started out as only a smart speaker. Now, Alexa also exists in your phone, your stereo, and your microwave. You no longer need a different operating system for each IoT device or smart speaker. Operating systems have been developing complexity in an opposite direction. That is, they are not any simpler in design and working, but are day by day becoming more complex. Current operating systems are traditionally built bottom up. Next generation operating systems start up with user. They are not anymore related to the hardware. These operating systems are less useful as compared to today's operating systems. Some features of future operating systems are user interface, knowledge navigator, multi-touch, self-automated, and self-diagnosing. That's all about my topic. Hope you all understood it. Thank you.